Hello everyone, today let's take a look at QP146 where we just bought one share of Fartcoin and we want to hedge it by shorting the S&P 500. So how many shares of the S&P 500 should you short to minimize the variance of the position? And what we're given to solve this problem is basically the variance of Fartcoin's return, which is 40, and the variance of the S&P, which in our example is 5, and their correlation coefficient, right? Well, there's not actually much financial stuff that you need to know in this question. You just have to know that basically shorting means that you bet that this one's going to go down, right? And when you buy something, you bet that it's going to go up. And whether it goes up or down or not for both of these is going to be a random variable. So I have F representing Fartcoin's return and S representing the S&P's return. Then if I let POS be the random variable representing my position, well, it's just going to be a sum of these two random variables, right? I bought one share of Fartcoin, so 1 times F, and then I shorted, basically, it's asking us how many shares should we short of the S&P 500. Well, if I call n the number of shares that I'm going to buy, well, then my position is just 1 times F minus n times S, right? Where I buy n shares of the S&P 500. And the reason we have subtraction here is because we are shorting the S&P 500, meaning we're betting on it to go down, right? So if S goes up, right? If S is a positive value, that means the S&P 500 is going up. And in that case, we're going to be losing money, right? So that's why in our position, we subtract off n times S. Similarly, if the value of S was negative, well, that means that the S&P 500 went down, which is what we were betting on, right? So then this whole term right here would be positive, right? And then we'd have plus n times S. So that would be us making money. So that's the random variable representing my position, where this is 1 times F minus n times S, so just F minus n times S right here. And basically what this question is asking us is it wants us to find the number of shares, so the value of n that basically minimizes the variance of our whole position, right, which is this whole term right here. So we're basically going to be solving for the variance of this term and then taking some type of derivative to find basically the value of n that minimizes it. So we're summing up and scaling multiple random variables here. So we know from QP41 that we can basically just express this as the variance of basically F plus the variance of negative n times S, and then we're going to have basically 2 times the covariance of all of our ordered pairs. In this case, there's only one. It's going to be the covariance of F and negative n times S. Now also from QP41, we can simplify this. We can pull out our constant right here, which is basically negative n, and we can square it. So we're just going to get n squared outside of this variance term right here. Again, just QP41 part A. Now I'm pretty sure we'll talk about this in QP147, but basically this covariance term right here, we can express it like this. This is just the definition of covariance. And then you notice that because of linearity of expectation, we can pull out this negative n from the whole thing, right? So we're just going to basically simplify this to being the covariance of F with S, and then we have to pull out the negative n, where the negative does not go away like it did for basically over here. So this is what you get right here. Variance of F basically plus n squared times the variance of S minus 2n times the covariance of F with S, right? Now the three values that we were given are the Fartcoin variance, the S&P variance, which are this one and this one, right? We're given these two terms right here, and we were given their correlation coefficient, which is not exactly this term, but it's related. So how is it related? Well, R is just equal to the covariance of F with S divided by basically the standard deviation of F. So just sigma F, not sigma squared F, but sigma F, and then sigma S, right? We talked about this in the discrete roadmap, right? So now we can basically solve for the covariance of F comma S because we know these two terms right here, or we know what they are when they're squared. So it's simple just to take the square root of it, right? So we know that when we rearrange this, the covariance of F with S is just going to be equal to R times the standard deviation of F times the standard deviation of S. So I can just replace that in my equation right here. It's just going to be R times sigma F times sigma S, or sigma S times sigma F. So now if we just write these in terms of how they're given in the question, we basically have sigma S squared and we have sigma F squared right here, right? So the variance of my position, F minus n times S, is just going to be expressed as this, where all of these are what we have been given, right? We were given R, we were given sigma S, and we were given sigma F, but we are trying to solve for n. We're trying to find the value of n that minimizes this value over here. So what are we going to do? We'll just take the partial derivative with respect to n of this side and set it equal to 0. So how do you do that? Well, let's just make some space right here. Well, we're trying to find the partial derivative with respect to n of the variance of our position. So the variance of F minus n times S, that's going to be equal to, well, for this term right here, it doesn't have an n in it, so it's going to go away. This term right here, the partial derivative with respect to n is 2n times sigma S squared. And then the partial derivative of this term is just going to be 2r sigma S sigma F. So now I set this equal to 0 to find the extreme points, and then when I do that, I'm going to get 2n sigma S squared. I can add this one to the other side, is equal to 2r sigma S sigma F. Now I can cancel a 2 from each side. I can cancel a sigma s from each side. So I'm going to have n times sigma s is equal to r times sigma f. So now when I solve for n, I get n equals r times sigma f divided by sigma s. So when n equals r times sigma f on sigma s, basically the value of the variance is going to be minimized. And we know it's going to be minimized just by some calculus, right? If I take the variance of my position, I take the second order partial derivative with respect to n of that, well then I'm going to get 2 times sigma s squared, right? Because this whole term doesn't have an n, so it's going to go away. And we know the variance of the S&P 500, well, it's some basically positive value, right? We're squaring it and then we're multiplying it by 2. So this is just going to be some value greater than 0. So at our critical point, right, our function is going to be concave up. So n is going to be a minimum at that point, right? This is going to be our minimum value right here. So that was us basically doing part B first, right? We found this value in general. And now let's just plug in our values from that for basically part A and see what we get. So we're given that the variance of Fartcoin's return is 40. So sigma f squared is going to be equal to 40. We're given that the variance of the S&P 500, so sigma s squared, is going to be 5, and we're given that r equals 0.95. So in our case, we're just going to plug in these values. R is 0.95. Sigma f is just going to be the square root of our variance for Fartcoin, which is just going to be the square root of 40, and sigma s is going to be the square root of 5. When you plug this into a calculator, you get something along the lines of 2.69. This means in this specific situation, you should short 2.69 shares of the S&P, and that will minimize the total variance of your entire bet. Now, what do all these numbers actually mean? Well, R is equal to 0.95 first of all, so we know that these stocks are very, very, very highly correlated with each other, right? So that means when Fartcoin goes up, we're going to have the S&P 500 go up as well, and when Fartcoin goes down, we're going to have the S&P more than likely go down as well. Now we also know that the variance of Fartcoin is a lot higher than the variance of the S&P 500, right? 8 times as high. So Fartcoin is obviously a way riskier bet, right? Even though I only bought one share of Fartcoin, I need to hedge by shorting 2.69 times the amount of Fartcoin that I bought for the S&P 500, right? Now, as the variance of Fartcoin goes up, this term right here will go up, which will make this whole n go up, right? Which means we are going to have to short more shares of the S&P 500 to properly hedge against this increased Fartcoin variance, which is exactly what we would expect. If we increase the variance of the S&P 500, well, then this term right here would go up, which would make n go down, right? The number of shares that we need to short decrease. That makes sense because as this one becomes more volatile, right, we need less of it to basically offset the volatility of this one over here. Now, finally, we know R can take any value between -1 and 1, where 1 is basically perfect correlation and -1 is perfect like anti-correlation. As basically R increases, as we get more and more tightly correlated between Fartcoin and the S&P, we're going to want to short basically more and more of the S&P. That is because A, the formula tells us so right here, as R increases, so will N, and it also makes sense intuitively because if these two stocks are more and more highly correlated, right, so they track each other more and more, basically the hedge is going to become more and more effective. And as R gets smaller, we're not going to be able to hedge as effectively, right? If R equals 0, then this whole term right here would be 0. That also intuitively makes sense because if there's 0 correlation between the two stocks, then it's going to be impossible to hedge one with the other because there's absolutely no correlation. But R can also be negative. So if R was equal to -1, well, then we'd get a negative value right here. So what does that even mean? How could we short negative shares? Well, shorting negative shares just basically means buying shares, right? So if they're negatively correlated, we can hedge by basically buying more shares. So that was just an overview of all those values. But now how much did we actually reduce our variance by shorting this specific amount of shares in our first situation, right? Part A, how much did we reduce our variance? Well, if you remember this equation right here for the variance of our position that we derived on the last page, well, let's just plug in all of our new values now. Now, the original variance of Fartcoin was originally equal to 40, so variance of F equals 40. So before I did any hedging, I had a variance of 40 just buying that one Fartcoin. Now, my variance after hedging with the optimal amount of 2.69 shares of the S&P 500 is going to be, well, if I plug in all my values, the variance of F was 40, n squared, well, n was basically just this one up here, so 2.69 squared times the variance of S, which was just 5, then minus 2 times n, so minus 2 times 2.69 times R, which was 0.95, times basically standard deviation of S and F, which were root 40 and root 5. When I run all this through a calculator, I get a final answer of somewhere around the lines of basically 3.9. Now you can see my variance has reduced quite a lot. The variance of one Fartcoin, which I originally bought, was 40, and now it's only 3.9 after hedging with 2.69 shares of the S&P 500, which is optimal. So 2.69 is the final answer for part A. When we plug in the values to what we solved for in part B, which was just this equation right here, n is equal to our correlation coefficient times the standard deviation of the Fartcoin divided by the standard deviation of the other one that we are shorting with, the S&P 500.